Hello, welcome to Flipped SG. So today we are on a topic of experimental chemistry, and this is the learning objective, which is to name appropriate apparatus for the measurement of time, temperature, mass, and volume. Okay, and for the volume portion, we have to know four apparatus in particular, which is the burette, pipette, measuring cylinder, and gas syringes. Okay, so as you can see, there are four of them here. 1, 2, 3, 4. Okay, let's go straight into the time portion. Okay, time. So, for time, okay, let's break it down into three portions. First one would be apparatus. Okay, that is to say, what instruments can we use to tell the time, basically. Okay, first is using a electronic stopwatch. Okay, second is using a mechanical stopwatch. Okay, so what's the difference between the both of them, you may ask? First one, it's actually really just more accurate than the second one. So more accurate up to a range of plus minus 0.01 seconds. Whereas for the mechanical stopwatch, it's less accurate with a range of only up to 0.01 seconds. Okay, second part to this would be to talk about its SI unit. Okay, so this serves as a recap as well. So the SI unit for time, okay, if you recall, is it's seconds, okay, which is a lowercase s. Next would be to unpack its, Next would be to unpack its unit conversion. Okay, I'm sure you remember as well. Unit conversion. Okay, and that is 1 hour, okay, will be equals to 60 minutes, which is equals to 3,600 seconds. And that's because 1 minute gives you 60 seconds. Okay, I'm sure this is what you have learned so far. Okay, so just a final tip, if you may. So if you have a question that asks you to suggest an apparatus to give the time, to take note of a time, which one will you choose? Okay, you want to choose the electronic stopwatch because it's more accurate. Okay, and that will be for time. Okay, let's move on to temperature. Okay, for temperature, okay, same thing, we'll unpack it into three portions. First would be its apparatus. Okay, so to take the temperature of a certain product, a reactant, we can use two instruments basically. First is a mercury thermometer. Okay. Second would be to use a alcohol thermometer. Okay. So what's the difference between mercury and alcohol thermometer? Okay. Basically, it's what's inside them basically. Okay, so for mercury thermometer, mercury is inside, and for alcohol thermometer, alcohol is used. So, but what's the functional difference? So basically, mercury thermometer allows for measurement of higher temperature reactants. Okay, so it measures higher temperature. Okay, whereas for alcohol, okay, it's to measure lower temperature. Okay, why? That's because mercury has a higher boiling point. Okay, hope that's clear enough. Okay, the second part will be to talk about its SI unit. SI unit. Okay, so the SI unit for temperature Okay, it's not what a lot of people think, which is degrees Celsius. Okay, it's actually Kelvin with a uppercase K. And so, how to convert from degrees Celsius to Kelvin? Okay, that will be unit conversion. It's actually very simple. Okay, please remember this would be to take K will be equals to degrees Celsius plus a 273. Okay, and that will give you Kelvin. Okay, and so that's it for temperature. Let's move on to mass. Okay, third one will be mass. For mass, let's unpack it in the same three ways. The first one will be apparatus. Okay, so there are two things to use here. First one will be electronic balance. Okay, second one would be a beam balance. So what's the difference between them? Okay, like in the case of time, okay, one of them is better than the other. Okay, so basically electronic balance is the one that it's more accurate and gives a faster reading. Okay, whereas for beam balance, it's less accurate and slower. Okay, so that's the main difference between them. And the next part to unpack would be its SI unit. Okay, for SI unit for mass is actually kilograms. Okay, and not grams. So kilograms, which is kg. So the third part would be to talk about its unit conversion, and that is okay, kg, 1 kg is equals to 1000 grams. Okay, so I hope that's clear. So similarly, if the question asks you to suggest an apparatus to give accurate measurement of mass, okay, you want to choose a electronic balance. Okay, finally, let's move on to volume. Okay, volume will be a bit more tedious in the sense that it has more things basically. Okay, so volume in specifically liquid, the volume of liquid. Okay, so firstly, if we talk about the apparatus needed, okay, we'll have actually four of them. First one being measuring cylinder. Okay, the second one, it's a pipette. Okay, third one, it's a volumetric flask. Fourth one being a burette. Okay, so for the measuring cylinder, it actually looks like this. Okay, it's a open cylinder with a relatively flat base. Okay, and there's marking on it. So when you pour a liquid into it, it fills to a certain marking, and you can see how much you have poured in. Okay, for the pipette, it actually differs from different designs, but usually there's a bulge in the middle, and that you can fill it with liquid and through the whole tube. Okay, so that's a pipette for you. Next one is actually a volumetric flask, which is usually covered. Okay, so it has a flat base as well. Okay, and like the measuring cylinder, it has markings. Sorry, it doesn't have marking. It has only one marking. Okay, for you to fill to that marking to give a very, very accurate reading of whatever liquid that you have poured in. Okay, last one would be a burette, which has the most distinctive design actually. Okay, it's a tube okay, with a knob here for you to control the flow of the liquid. Okay, so when you pour the liquid in, you can actually control its flow rate. Okay, so what's the difference between all four of them? Okay, measuring cylinder, okay, depends on the size. You can measure 1 cubic centimeter to 1000 cubic centimeter. Okay, but the drawback is that it's rough gauge only. Okay, rough gauge. Okay, means that you cannot get a very accurate reading using a measuring cylinder. So when you see the question asking you to suggest equipment, apparatus to give a rough gauge, okay, measuring cylinder should come to your mind immediately. Okay, next will be a pipette. Okay, so for pipette and volumetric flask, they are similar. Okay, let me go through pipette first. Is to measure a fixed volume. Okay, as a, for example, 25 cubic centimeters. Okay, and this is true for pipette. Okay, and it's very common to have 25 cubic centimeter accurately measured. For volumetric flask, it's the same thing. It also measure fixed volume. Okay, but it has a bigger capacity than pipette, so it can measure 25, 250, or 500. Okay, so etc. It has bigger capacity than the pipette. Finally, the burette, it's variable in the sense that it can measure any volume that you want, but it's very less accurate. Okay, so in terms of accuracy, okay, let me rank them. Pipette and volumetric flask, they'll be number 1. Okay, burette comes in at second, and measuring cylinder would be third in terms of accuracy. Okay, hope that's clear. Okay, let's move on to the SI unit. Okay, so the second part for this whole volume, okay, liquid volume, number 2, would be to talk about its SI unit. Okay, its SI unit is actually, okay, let me change color right here, it's actually cubic meter. Okay, which is meter to the power of 3. Okay, so this is cubic meter. And to convert it from different units, let me show you. Okay, would be that 1 cubic meter would be equals to 1000 decimeter cube. Okay, and 1 decimeter cube is the equivalent of 1000 centimeter cube, which is 1 liters. Okay, so hopefully that's clear. Okay, finally let's move on to the last section, which is the volume for gas. Okay, this is a very, very short section, and it only actually covers the first one. The first section, which is apparatus. Okay. And only one, so it's really just gas syringe. Gas syringe. So if the question asks you to suggest a method to collect gas, the only answer you would choose is gas syringe.